Word embeddings gave every word its own vector, which is wonderful, until you need to compare two whole documents rather than two words. The obvious fix, just averaging all the word vectors in a document, quietly throws away word order and blends everything into a bland, mushy average. Surely we can do better than that. What if an entire paragraph, or a whole document, could earn its own single vector, trained to capture what the text is actually about? That is precisely the idea behind Doc2Vec, and it is a beautifully simple extension of Word2Vec. Let's get into it. First, let us see the problem this model is really solving. The quick fix for embedding a document is to average the vectors of all its words. It is easy, but it treats the text as an unordered bag, so word order vanishes entirely, and a long document collapses into a bland average where every distinctive idea gets diluted by everything around it. You lose exactly the structure that makes one document different from the next, which is precisely what you needed to keep. This method instead learns one dedicated vector for the entire piece of text, trained on the actual document rather than stitched together afterward. Because Doc2Vec is optimized to predict the words that appear in that document, it captures the topic and style of the whole thing in a single dense representation. So how does this model actually learn that vector? Follow the loop one step at a time. Give every document its own unique identifier, a special tag that comes with its own trainable vector, starting out as random numbers. Think of it as an extra token that stands in for the whole document, sitting right alongside the real words. Now slide a window through that document. At each position, take the document's tag vector and combine it with the vectors of the surrounding context words. The document vector rides along with the ordinary words as a kind of persistent memory of the text. Train the whole thing to predict the next word from that combined input, nudging both the word vectors and the document vector to do better. Because the document tag is present for every prediction across the text, it slowly absorbs whatever is common to the entire document. By the end, that single document vector has learned to capture the overall meaning, the topic and style that help predict its words. A faster variant, distributed bag of words, uses the tag alone to predict random words, and to embed a brand new document, you run a short inference step to fit a fresh vector. Boil it down, and three ideas define this model. At its heart, Doc2Vec learns a single dense vector for an entire piece of text, whether that is a sentence, a paragraph, or a full document, not just for the individual words inside it. The magic is the document tag, an extra vector trained right alongside the word vectors in the very same prediction task. It acts like a memory that soaks up whatever is distinctive about that particular text. This gives you a way to embed variable length text into one shared space, so documents of any length can be compared, clustered, classified, or retrieved by similarity, all with plain and simple vector math. A tweet and a long article both become a single point you can measure against every other. All right, let's lock in the essentials. This model, also called paragraph vector, extends Word2Vec to learn a single dense vector for a whole sentence, paragraph, or document. A special document tag is trained alongside the ordinary word vectors, absorbing the topic and style of the whole text as it learns to predict its words. This lets you embed variable length text into one space for classification, clustering, similarity, and retrieval, all with simple vector comparisons, which made it a popular tool before neural sentence encoders arrived. Its downsides are a fiddly inference step for new documents and being largely superseded by transformer sentence encoders. Yet the core idea stays clean and lightweight. If you like seeing machine learning ideas stripped down to their simple core, that is our whole habit over at Standarity.com. We will see you there.